This video is about using the properties of real numbers to simplify expressions. This is lesson 12 in your book, and it's on pages 63 through 68. First property we're going to talk about is the identity property. The identity property of addition states that for every real number a plus 0 equals a. Basically, it means that anytime you add 0 to a number, it maintains its identity, or it stays the same. For example, if we wanted to pick a real number, say 4, and add 0 to it, that number would maintain its identity, or it would stay 4. So that is the additive identity property. Multiplication also has an identity property. It says that for every real number a times 1 equals a. Or, basically, if you multiply a number by 1, it maintains its identity. If we used a different real number, say 7, and multiplied it by 1, it would maintain its identity, or it would stay 7. So multiplying by 1 is the multiplicative identity. Then there's the commutative property. The commutative property for addition says that for every real numbers a and b, a plus b equals b plus a. This means that the order of the numbers does not matter in addition-only problems. For example, if I wanted to pick two real numbers, say 1 and 2, I can say that 1 plus 2 is the same as 2 plus 1. For multiplication, the commutative property says that for every real numbers a and b, a times b is the same as b times a. So if I wanted to pick two real numbers, say 5 and 7, I can say that 5 times 7 is equal to 7 times 5. Now this is the commutative property because it says that the numbers can commute, or move from one place to another, without changing the value of the expression. So the numbers can change places in addition-only problems, or they can change places in multiplication-only problems, and not change the value of the equation. By the way, you do need to write the identity property on the last page, the commutative property, and the next property that we're going to talk about in your notes. Now there's the associative property. Again, you need to write these properties in your notes. The associative property for addition says that for every real numbers a, b, and c, when you group a and b together and then add c, it's the same as adding a to a group b and c. What it means is that you can associate different numbers in an addition-only problem and still maintain the value of the expression. So if I were to pick three real numbers, say 4, 5, and 6, and I added 4 plus 5 in parentheses, and then 6 on the outside, I would get the same value as if I had 4 plus, and then in parentheses, 5 plus 6. When I simplify this side, I get 4 plus 5, which is 9, plus 6. And here, I get 4 plus 5 plus 6, which is 11. Now when I add these two, I will get the same value. 9 plus 6 is 15. 4 plus 11 is also 15. The associative property of addition says that I can group the numbers in any way I want in an addition-only problem, and it doesn't change the value of the expression. The associative property of multiplication says that for every real numbers a, b, and c, a times b in parentheses times c equals a times in parentheses b times c. Now if I use those same real numbers 4, 5, and 6 and I group them differently, so 4 times 5 in parentheses and then times 6, it would be the same as putting 4 outside the parentheses and 5 and 6 inside. Here when I multiply 4 times 5, I get 20 times 6. Over here I've got 4 times, and 5 times 6 is 30. And on either side, when I multiply, I'm going to get the same value, 120. So the associative property just says that it doesn't matter which way you group the numbers, you don't change the value of the equation. Here we want to identify the properties that are being used in these situations. These are examples and they all need to be written in your notes. The first one has 1 times 8 equals 8. Now we know this is going to be a property of multiplication because we're multiplying here. The difference between this side and this side is that we're multiplying by 1 and getting the same number. Basically, the real number in the problem, other than 1, maintains its identity. So this property is the multiplicative identity. I'm going to abbreviate this, multiplicative ID prop. Multiplicative identity property. Because we're multiplying a number by 1, and that number is maintaining its identity. Now let's look at this one. 13 plus 5 equals 5 plus 13. Obviously, this is an addition property because we're adding on both sides. The difference between this side and the right side is that the numbers have switched places. They have moved from one place to another. And the property that deals with numbers being able to move from one place to another is the commutative property. So when I say what property this is, I'm going to abbreviate it, but it's the commutative property. And I need to specify that this is the commutative property of addition. This third one here has 3 times 4 in parentheses times 7, and it's equal to 3 times, in parentheses, 4 times 7. Now we're not multiplying by 1 here. It is a multiplication property because we're multiplying, but we're not multiplying by 1, so it can't be the identity. And the numbers aren't moving from one place to another. They're staying in the same order, so it can't be the commutative property. The difference here is the parentheses. We're grouping 3 and 4 together here, and 4 and 7 together right here. So we're dealing with how the numbers are grouped. And the property that deals with the grouping of the numbers being able to change is the associative property. So this is the associative property, and I need to specify that it's of multiplication. Now let's look at the fourth one. This one's a little tricky because it does deal with, it's got some parentheses here, so we automatically, by reflex, want to go with the associative property. Now, since our gut instinct is the associative property, let's look at the parentheses. Here the parentheses are around 12 and 9, so they contain a 12 and a 9. Over here the parentheses are also around 12 and 9. Since what's in the parentheses hasn't changed, this is not the associative property being demonstrated. Now, this is definitely the addition property that we're dealing with. It can't be the identity because we're not adding 0. But notice that 12 comes first here in this left side, but 9 comes first on the right side. The numbers have moved from one place to another. And when the numbers move from one place to another, that's our commutative property. And again, we need to specify that it's of addition. This is another example. It needs to be in your notes. We want to tell if this statement is true or false and justify using our properties. So we're going to start with this one. G times H equals H times G. So this says that if we multiply two numbers, it's the same as switching their order. Now, is that true or false? It's definitely true. And when we justify, the property that we're going to use is, sorry, that shouldn't have started with a P, is the property that tells us that this is true. It's the property that tells us that in multiplication, numbers can move from one place to another without changing the value of the expression. And that is the commutative property. Of what operation are we performing here? Multiplication. If we look at the next one, we've got b plus 1 equals b. That says that adding 1 to some number maintains its identity. Is that true or false? Well, we know that if we take a number and we add 1 to it, it's going to change the value of that number. If we add 5 plus 1, it's going to change the value of the number, and it's going to be 6. So this statement is false. And the statement that says that that's false is the additive identity. What can we add to a number that would not change its identity? Well, we can only add 0. So the additive identity says that if we add 0 to a number, it stays the same. This is adding 1, so it must be false. Here's another example. Again, it needs to be in your notes. We want to tell if this statement is true or false and justify using our properties. It says that d plus e plus f is equal to d plus e plus f. So it's telling us that if we switch the placement of the parentheses, the expression remains the same. This is true. And it's true because of the associative property of addition. Here's another example that needs to be in your notes. We want to justify the steps to simplify this expression. So we're going to simplify it, and we're going to justify every step that we make. Now I'm going to start by saying I can't add 16 and 3x, and I can't add 3x plus 4. So I'm going to switch the order, and I'm going to say 16 plus 4 plus 3x. Now what property tells me that I can do that? That's the commutative property. So my justification here is the commutative property. Now I'm going to combine my like terms. 16 plus 4 is 20. So my justification here is combine like terms, or add. And since there's nothing left to do here, I can say that this is the simplified form of this expression. And here's our last example. Be sure to write this one down. We want to simplify this expression and justify our steps. So here I've got 25 times y times 1 over 25. Now I can multiply 25 times y, but I think I'm going to switch the order, and I'm going to move y over here and 1/25 over here. So I'm going to say 25 times 1/25 times y. Now, what property tells me I can move the numbers from one place to another? That's the commutative property. Now I'm going to multiply 25 times 1 over 25. I know that when I multiply a number times its reciprocal, I get 1. That's the inverse property of multiplication that tells me that I can do that. And that inverse property of multiplication was discussed in lesson 11, I believe. And since 1 times y is just y, and I know that because when I multiply a number times 1, I get the same number, that is the identity property. And my simplified form is just y.